Yeah, that's what I'm here for.
I have very little understanding of Kubernetes, yet I use it every day.
There you go. Well, that's fine. That's the goal. That's actually why I'm here, is to use it so everyone can use it even more without having to have an understanding of it. This is the Women Who Go, right? Do I get an award for bringing the only one?
Yeah, I was going to say that. You should.
There were so many RSVPs on Meetup. I know they're trying to.
There were 10 RSVPs.
I thought there were more than
By
that.
the time I asked him,
I could have sworn.
I forgot about the
But there were more RSVPs on Meetup?
Which this is still so much better than Open West because you have reads.
Yes.
And
It doesn't
share.
take much to be better than Open West. We established that 2 years ago. Okay. It doesn't take much to be better than Open West.
I know. I give them. I'm giving them crap, but I would say
This meetup is,
It's okay, Clint wants to take it over.
more special.
I've heard that.
Well,
go groups in general.
I think.
Someone else needs to take over.
Someone has to.
Yeah.
She used to go every year, and there were times where I remember it sounded like it was really good,
Okay.
at least reasonable.
That's a good point.
Hold on,
Hi,
I need to
guys.
move so I don't talk over you.
My name's Mariah.
Wait, we announce our job offers and stuff?
No, I don't announce. I run too many meetups. I run way too many meetups to be able to ethically recruit for week. So I don't. If anybody else had, Taylor does not run any meetups. So you can ethically recruit for week.
You guys want a job?
I'm already coming, so there's.
Anyone who's not Carson want a job?
So yeah. So this is Women Who Go. The purpose of Women Who Go is to provide great content, just like all other meetups. And then we just want to provide an environment where women feel safe. Hence the name. Otherwise, I don't care who comes. We're inclusive. So this isn't the only time that we've had 90% male attendance. There was a time where we had 90% female attendance. That was pretty good. So we're hit and miss, but this is not as low level as a lot of the topics we usually cover. But I'm practicing for a conference talk, so here we go.
Who are you speaking? Oh, is it
Go
this?
for Palooza.
Okay, yeah, that's right.
But so yeah. I'm Mariah. I title myself a machine learning engineer here at Weave. I run a bunch of meetups. We're getting a Go conference together for Salt Lake in May. So I'm really excited about that. We have Bill Kennedy coming to do the Ultimate Go workshop. And we're getting somebody from Google to come do a keynote. So we should be getting some decent people there. And then I expect Carson to submit an abstract because he does. I want to say that this talk is not going to dive into machine learning. I'm not going to address doing machine learning in Go versus doing it in Python. I'm not going to say what's the better language. I'm not going to talk about a whole bunch of different tools. I've done that in previous talks. The goal of this talk is to kind of bridge a skills gap that we find in the data science machine learning community. And that skills gap can be often filled by software engineers. Data scientists are really good at taking data and figuring out what model fits it best, and optimizing all of the parameters. So then they have a really optimized model written in MATLAB that nobody can use. They're not good at getting the data, getting all this random data, putting it into a warehouse and aggregating it, making good. That's what software engineers do. Anybody who's built a data pipeline will title themselves data engineer or software engineer. Anybody who's been in software for more than 5 years has built a data pipeline. Anytime you put data in a database and then pull it out of the database, that is some version of a data pipeline. Software engineers are really good at that. Software engineers are also really good at creating endpoints, at getting information out, at creating services at an enterprise scale. This is what you do with the model after you've built it. So you have software engineers who are really good at doing everything that machine learning engineers can't do, which is taking a model and using it. So The gap is we have a whole bunch of machine learning engineers, data scientists who have this lingo that software engineers don't know. But with a bunch of simple explanations, simple skills, we can bridge that gap, get a basic understanding, build this communication, and start bridging that gap so that software engineers can get into the machine learning space and we can start pushing things out to production, building better systems, automating things, and iterating on our models so that they become better over time. So that's kind of the goal, and I'm choosing to use Go as a format to talk about this.
Great.
Because I like to do machine learning in Go. I'm one of the 5 people that does it, so.
Okay, just before you, the slide, since you put it up there,
Dog mom?
what breed is that?
Beagle Yorkie, so he's a Borkie. He's a very spoiled Borkie who, if I'm at a meetup, he's 90% of the time at my parents' house. So let's start with, I'm gonna cover just basic concepts in machine learning, things that I think are really easy, that aren't neural networks, but that any software engineer can implement in a production level, and then in an enterprise model and scale out in that way. So we'll start with just a simple thing. The very basic is machine learning replaces your switch statement and handles all of your edge cases. When you start getting switch statements that have 20 different cases with a whole bunch of edge cases that you may never hit, but you know you need to have so that your system doesn't break, that's what machine learning does. It takes care of all of your edge cases. It doesn't help if you're doing a simple if-else. If there's only 2, that's not what machine learning is good for. But machine learning basically is taking a whole bunch of data and creating this switch statement for you. That's what it does. Using data to create a switch statement. That is the simplest explanation of machine learning. You look like I'm lying to you. I promise you I'm not.
Okay, you correctly read my face then, yeah. You mean literally it ends up being a case statement?
Yeah, with hundreds of cases.
Okay.
I'm saying if you want to sit there and explore every single possible case and write out hundreds of them, thousands of them,
So after you did some machine learning,
it's not going to come out looking like that, no.
okay, that's what I,
It's not
so
going to
literally
look,
it's not
We're
that.
gonna generate a switch
Excuse me.
statement.
it
All right.
does the same job as your switch.
Same
statement.
job, okay, because
That's what I meant to say.
I'm sorry, my smoke detector was going on.
No, yeah, no, thank you. So, but so what you're doing with your switch statement, trying to catch these cases, that is the same thing that a machine learning model will do. I need to know, see, I told you I'm practicing, so those things do help. When you catching me on that will help me in the future. The goal is, you're trying to build a service to solve a problem. Whether that service be figuring out if it's cat or dog, whether that service be figuring out where an object is in a picture. These are just common things that a lot of people think machine learning should be used for right now. You're trying to find a model that best fits your use case, right? There's a whole hundreds of models that you could use to figure out if a picture is a cat or a dog, but one of those models is going to do the job better than another model based on your data set. And the idea is you want to be able to get the result repeatably. You want it to be able to be reproducible. Very similar to kind of what we do, what's done in software. We want things to be reproducible. We want it to do a job. The difference is we usually don't just throw terabytes of data at a problem and hope it gets solved. In software, there's a different strategy to it, but it's similar. It's a similar process. These are very common types of problems that machine learning is famous for. The first one is pattern recognition. I don't know if you've ever heard of a GANs, but what they do, it's called a generated adversarial network, and they figure out what patterns are. Well, what they did one day was they just put a whole bunch of people spaces in it, and that GANs network figured out the pattern in structuring people spaces. So if you go to thisisnotaperson.com, you will see a GAN-generated image of a person. This is not a real person. It was generated by GANs, but It looks dang close because they figured out what a human looks like based on just pattern recognition, shapes, and all those great things. Predictions. All financial companies in stock market, anyone who's in the stock market, they're using prediction models for machine learning. They're trying to figure out what's happening next based on what's happened in the last 3 billion seconds. These are per second live iterations on models and changes, and they care about what's happening in the next 5 hours. You can do it not quite as quickly. You can do things bigger. For example, AT&T forecasts outages on their network. They have data of all of their outages. They built a model for that, and they forecast where the load's going to be heaviest so that they can send technicians to be able to handle big, massive network outages. Different kinds of predictions there. And another one is a lot of the use cases are just classification. Most famous one, and one of the earliest use cases for machine learning in a production level, was your email spam classifier. All of your email services use it right now, and that's how they figure out what emails are spam, and they automatically send it there. That's just a simple machine learning model, just a binary, is spam, not spam, based on a whole bunch of features that they pulled out. There are several different kinds of ways to build these machine learning models. The 3 most common are supervised learning, and this is very similar to your classroom type learning, where you're presented with some information and you're told that's right or that's wrong. You're told 2 + 2 does equal 4, 2 + 2 does not equal 5, a true and a false statement. So with that, your supervised learning, you're providing it a whole bunch of information with a label. This is true, this is false. This is a cat, this is a dog, based on all of these features. Supervised just means you're also giving it the answer so it can learn what that answer means or find the connection between the true answer and the false answer.
So it's not trying to find the answer, it's just trying to
It's trying to understand why that answer is, not trying to figure out
what the answer
what the answer is. Supervised learning ends up being more of the aha moment, the eureka moment. It gets a whole bunch of data and then infers stuff from it. So this is often used in clustering to find out different, clustering ends up being what you end up seeing. They'll take a whole bunch of data and then it'll start grouping it for you. So it'll find patterns that you didn't see before.
Is that where the case statements come in? Like it makes its own case statement?
It'll be all different kinds of things. Something very common that this is how Ancestry, this DNA model, actually ends up working. It pulls in all of those DNA and then it starts grouping them into different groups. Then you have a biochemist person figure out what the patterns are within the groups, then they can start applying it to regions. They just pump in billions of data points of DNA, and those get grouped together, and then they understand what those groups mean. So the data figures out what the pattern is without knowing what you're looking for, and then you figure out what it gave you. And then another famous one is reinforcement learning. This is what they use in your gameplay. The idea of reinforcement learning is you give your model, your machine, a set of actions, and it keeps doing those actions till it figures out what's the quickest way to get the goal. So if its action is put the square in the hole and you give it 5 holes, it's going to put it in any hole until it finds the shortest solution, which is obviously take off the lid and just stick it in the box. And then it'll start doing that every time instead of hitting the wrong hole. That's reinforcement learning in a nutshell. So if you've done any machine learning in Python, Scikit-Learn is the most common library. That does basic machine learning, non-neural network. Everybody uses it for everything. GoLearn was written to be the Go language equivalent for Scikit-Learn. So it does all of your basic machine learning functions before you get to your neural nets. If you want to know the difference between the regular machine learning and neural nets, we can talk about that later. That's not what I'm trying to get at in this talk. But basically, GoLearn will cover 90% of your use cases. I want to talk about the first use case. This is the idea of linear regression. I like to consider it your everybody's done this before. You go back to junior high, high school, they give you a bunch of points on the graph, tell you to draw a line of best fit. That's linear regression. You're drawing a line of best fit with thousands and millions of data points.
This is the hello world.
Yes, it's essentially the hello world of data science. The idea is here that you give a whole bunch of data, and this data is supervised. This data has a yes and a no, a true and a false. For example, for this one, we have data that says this is spam, this is not spam. We draw an arbitrary line. When it starts, it just draws the line. And then it calculates an error. It says, okay, how far away are the blue dots from this line as opposed to how far away are the red dots from this line, right? We want to be getting right in the middle. We want to be limiting the distance of the dots from the line. That is the idea. So, as you can see, it just starts it right there. Or go back, go back, go back. There we go. See how it just plots it right there and then it starts moving it? It could have moved it in either direction. It's just kind of random at first until it calculates a loss. Once it sees the loss starts to get smaller, it'll keep moving in that direction until it gets super close to 0. And that's when it says it's a fit. You're just getting the terminology for this is just y equals wx plus b, where w is the weights, b is the bias. So bias is how far it is off the line, and weight ends up being the equivalent of your slope. So that's basically equates to how far the points are from the line affects your weights. Pretty simple, and this covers most of your binary yes/no situations. If you have a third case or a fourth case in there, you can actually have multiple lines that you just put on top of each other. It becomes a little bit more tricky of a problem to set up, but you can still use the multiple line situation. You can actually start using curved lines if your data does not follow a linear pattern. This ends up being different kinds of regression. You have logistic regression, you could have not linear, but you could have like a squared regression where it's actually a polynomial, like looped equation or any other kind. Ones that take this S form follow the logistic regression pattern, just because of the type of equation that you have. It's called the sigmoid equation, hence the S. It's the same process as linear equation, you're just not fitting a line, you're fitting a different curve. Oh, okay. So, I forgot what my slide was. Let's walk through it. We have a whole bunch of data here. This data represents advertising dollars spent on TV. So this is the money spent on TV. And these, so for example, if you're selling shoes, this is the amount of money spent on TV advertising. And this is the number of shoes sold. Okay, we have a whole bunch of data points.
Does each point represent a different ad or?
Yeah, it would be a different ad campaign, right? So if you have 100 different ad campaigns, you put this one 280 times on TV, and you were able, how many sales were built in from that. So with GoLearn, it's not hard to implement. Basically, you just take your CSV file. I hope that's decent to read. It's kind of small. I should have made it bigger.
What's the color scheme? Yeah.
It's more the color.
You don't like the colors?
I like the color. It's just the clash against the background.
Well, I was trying to make it not the same color as the background.
Is that your screen? Is that the colors you have on?
Well, I always program in black. I was just changed it to make it contrast against the background. You're saying in the future you want me to not do that?
No, you can just overlay it right over there and use like a dark background.
Okay, I'll change
I'm
that.
not gonna have.
Or darker text, yeah.
I'll change it in the future.
So,
Yes?
no, I'm sorry.
Okay.
I'm trying to press your stuff.
So you just basically, you take a CSV file. That CSV file is going to have a whole bunch of data points, and then your label at the very end, right? The label is how many things we sold. So it would be 25 would be a label, 15 would be a label, 5 would be a label. And then this would be what we call a feature, the number of times it was on the TV. So we're taking the CSV, which has all of the labels, and then the feature at the very end, and we pull it out in the data. Then we do what's called the train test split. Come back, go back. I'm not ready for that yet. And basically, testing is how we know that we have something that's repeatable in software. We do the same thing in machine learning. So what we do is we pull out a part of our data set to test on later. We don't use that to understand what's going on. We use it to validate what's going on. And they're labeled so we know how it ends up.
That's 0.70 is the
So
the
70,
percent is your data.
so 70%, so 70% of our data will be used for training, 30% will be used for testing. And this instance actually pulls them out randomly. So we're not taking the first 70, we're just, it iterates through and pulls them out to get that split. We don't want it to be linear because you could have put the first 20 being highest and the end, you know, the end could be all the low ones, right? We could have, the organization of it shouldn't affect. We want it to be as random as possible. We define a linear regression algorithm. Those 90% of the time have already been defined in whatever package you're using. And then we just take our train data and we fit it. That defines our line of best fit. And then we just take our test data and we do a predict on it. And that predict is going to actually create a nice little line that we can then apply to it, and that becomes our line of best fit.
So you said that the algorithms are already.
GoLearn.
Okay, so GoLearn has sets of.
Yep, so these things were all defined in GoLearn.
That's not like you're gonna have another package that you're injecting.
100%. No matter what you're using, what package you're using, whether it be GoLearn, PyTorch, TensorFlow, Scikit-Learn, the ones that exist in Java that they're technically in Scala, but that's really Java. They're already defined. You should never have to define the model. You might have to change parameters, not hyperparameters, but that's just basically saying, okay, I want to run this 5 times versus 10 times to get a train. Or, hey, I want to, it comes more into play with neural networks. So you might be tweaking certain ways that it's trained, but you should never, 90% of the time that data scientists will define the model and write it out in a way that you can just implement it in your production system. So it becomes more of an understanding what the model does so you know how its results are going to work than it is implementing the model itself. We'll go over what the tests mean later, but you can also test it to understand how well your model does so that you can communicate to a client the effectivity of what you're producing, right? So people don't just, you know, you want to communicate false positive, false negative, same that you would with a strep test, just so that they know that you're not promising the world there's going to be glitches. Another one that's very common in machine learning is a decision tree. I was told that this is the workhorse of machine learning. And this is basically works like your common flow chart, which you use to describe case statements when you're doing an architecture diagram. So like I said, it does the same job, but you get a situation. Okay, so you get a situation, you get a feature, and it says, okay, some of my data behaves this way, the other half behaves this way. And it gets a second feature. And so some of the data behaves, then it starts splitting it until you get certain classes, right? So for example, if you were doing a cat and a dog, it would start looking, okay, first let's look at the ears. If it has pointy ears, we'll put it here. And then if it has flappy ears, we know it's most likely a dog, so we're gonna put it on a different path. Then we'll go over here and we can look at the nose. We know a cat nose is going to be very different than a dog nose, so we can take those pointy ears and then we can go on nose, you can do eyes, you can go all the way down. These can reconnect later if you're just doing a binary thing, but it allows you, the model will detect these different features and build it out that way in the nature of your case statement. But you don't have to write all of the cases. And it ends up being you can measure, it is probabilistic, it's a statistical model, that's how it's implemented behind the scenes. So I built one from scratch. This was my work. I decided, so I'm gonna run through just basically an end-to-end, all of that a software engineer would do to implement this model from raw data on. So I went on Kaggle and I said, okay, I want some data. So I went and I pulled down a CSV of a whole bunch of tweets for the FIFA World Cup in Russia last year. So here you can see we've got a nice CSV file, and I just printed out a table just so you can see what's in there. So they just have an ID that's non-repetitive for a unique ID. 90% of the time you won't use that in the model, but if you're ever, you know the use case of that in the database, it's necessary to have a unique ID. We know that they're English, the date's not readable, they come from Twitter, they have how many characters are there. And if you go down here, they have a whole bunch of columns that aren't showing. We have the tweet in its original form, we have the number of likes, number of retweets, we have if a username was mentioned, we have the name of the person that was there, we have Twitter's user ID, and all kinds of other things in there. So I figured, okay, well, what of this data is actually actionable? And so I decided, well, I have labeled names, and I have labeled user mentions, so these are all going to be usernames or actual names, such as mine would be Captain Nobody One is my handle, and that would be a user mention, and then my name would be Mariah Peterson. So those are two things that are labeled that I can take out. And then I also have the words in the tweet. So I made an assumption that's kind of broad, but it's applicable. I decided, hey, I'm gonna pull everything out that's a word, and I'm gonna label it. So what I did was I took the CSV, I pulled out all the names, and I labeled that as is a name. And then I took out all the username mentions, and I labeled that as is a name as well. And then I took out all the tweets, and I just did a simple match on the word. I said, if this word in the tweet matches the name, we're gonna skip it. If it doesn't match a name, we're gonna classify it as not a name. And just assume that I've hit most of the cases with name and user mention. That is not accurate. Human labeled data is always better than something you throw together, but it was close enough for my example. So, but stuff like that can be automated relatively easily for that nature. And if you had a model, then you could apply the model and then use the model to label in the future. So after that, I had a CSV file with words in it labeled name or not name. So I just pulled it in to a data set, basically a separate table that GoLearn understands, and that's called words. So that words is gonna have a name with a yes or no, is a word, sorry, a word with an is name or is not name label associated to it. And I had it, then I split it just using the 70-30 into a train test thing. Still randomized, nothing complicated yet. Now I defined a decision tree. There are several models implemented in GoLearn that just have different statistical models within them. So the one that I got the best result from was called the gain ratio rule. So this is just a different way of calculating error based on the model, and that just defines the nodes that come up in your decision tree. And nodes, when I say node, I'm talking about the decision point, the one that splits off. That's what you would have your node be. And so you define that, pull in the model. This 0.6 right here is a weight. So that's going to be a little bit of randomness that you put in on the switch. That allows you to understand your edge cases slightly better. So it might mean you're replicating a decision a couple twice, like in 2 sequential nodes, but it just allows you to understand edge cases, right? You want it to, if it says the same thing twice, it's more likely to be true.
So what is a higher value versus a lower?
Higher values tend to increase randomness within it. This can be good and bad. When you're trying to judge error, the higher it is, generally speaking, the more chaotic it is and harder it is to understand the error. So generally speaking, it'll be less than 1 all of the time. If you're bigger than 1, you just have increased too much chaos, too much randomness. Less than 1 is better. For this use case, I don't necessarily know what that weight does exactly, so I can look that up and bring it in as far as it relates to the gain ratio model. But I can tell you for a fact, it's just determining a level of randomness in calculating your error.
So you just tweak it around.
Exactly. So changing that, that's one of the hyperparameters that you might change to get a different result when you're implementing a model. But you'll be within, like, if it's less than 1, you might go from like 0.1 up to 0.9. I mean 0.01 up to 0.9 and take large steps just to see what's better and narrow it. So you're not doing a whole ton of exploration there. That's kind of just the range that you're expected to fall into. When you do fit, the result actually comes back on the tree object. So this object right here contains your model, and fit's gonna save the model within the tree. That's why we don't get a result next to the error. And then we just test it. So we're gonna take our test data, and we're gonna use our model to fit it and see what we get. See if it matches what we expected, right? We're gonna figure if it decides this is a name, this is not a name. And we're gonna print that out in what's called the confusion matrix. And all the confusion matrix does is it confuses us. It's a way of explaining true positives versus true negatives, false positives and false negatives, right? So a true positive means, in this case, it was a name and that's what we predicted. True negative means it wasn't a name and that's what we predicted. False negative means it wasn't a name, but we predicted that it was a name. And false positive means it wasn't a name, but the model said it was. So that's what there's 4 cases, so it's a square, hence matrix. Confusion, I don't know why they put that in there, but it is kind of confusing until you have it explained. So, and so it did just print it out. And then right here, we're saving the model in a .h file. That's a very common format. And that just saves your results so that you can pull it up into a different program, right? You wouldn't want this sitting on your server to be running and training all the time. But if you have a model that you like, you can take that up, pull it out, like we did the last time, put it in predict, and then have an endpoint that hooks up to that endpoint that feeds in data, predicts on it, pulls it out. So you're not running the training over again, you're just taking your saved model, putting it in a different service that might be wrapped by an endpoint, it might be wrapped by whatever kind of, what do they do, webhooks,
So I'm gonna
event
guess,
services, something like that, just to put the data in, run a predict on it, and throw your results back out.
training probably takes, it probably gets better the more data you give it and takes longer, so you want to be able to do the training.
Exactly. You would want the
Save.
training process to be separate from the actual deployment to production process.
I was curious what that file would look like. Not a big switch.
I can show it later. I have it saved on my computer. I'll pull it up after I'm done with this.
It's not a switch statement.
It is not pull up. It is very much a gross binary mathematical file.
Ed.
Okay.
There are other formats to saving it. .h5 is very common in Python. Onyx, I should go back. But when you save it in a .h file in Go, that can only be read by a Go program. The compiler has something to do with that. Same with Python. Onyx, that's ONNX, is a format of saving models that can be read by different languages. So it's kind of a neutral form. It's newer. but there is one in Go, so that would allow you to take a Python model, save it in Onyx, and then put it in your Go program, read it back in and predict. So that's a thing in the future. If you still want Go, you can still train in Python and then deploy it in Go. You don't have to come back and use Python again, if you like, because Go's better. Yes?
So I have a couple of them, but you can cut me off at any time. How big do these .h files get on average?
So for a neural net, it'll be bigger, but you can think of this as being, well, we'll pull it up. It shouldn't be more than 100 lines of code. These are very small files, right? This is just the results. So for a linear model, this is literally going to be a function. Put in data, it fits it on the function, spits out a yes or no, a binary option based on that line.
So it might not be an actual switch statement, but it's about the same.
Oh, it performs, yes. Yeah, because it performs the same way. It'll just be more of a mathematical interpretation of it as opposed to the logical that we're used to seeing. But it will not look like a switch statement, I promise you. But it does the same thing. Did you have another question for that, Taylor?
Yeah. So when you're loading it into a Go program, you're loading it from a file and loading it into memory, and then
Well, it would run just like any code you had in Go. So right, it would run in your compiled Go program.
right. But you've taken this file, this dot.
So I'm saying if I were to write a second program, that its whole goal was just to predict, just to give, that's called inferencing, just to give the results of my model. If the whole purpose of that was to inference, I could go back. I could define new model, and then instead of doing new this, I would put that H file there. And so I wouldn't do new, I would say load decision tree, and that would give me the same tree object, but it wouldn't be an empty struct, it would be a full struct. That's the equivalent in Go. And so that full struct would then have all of the information that this tree had before. Where'd it go? It was right there. Yeah, so it would just basically have all of the information that the tree had before, and I could run this on it, but instead of doing it on a whole bunch of data, I would do it on one data point and then get the result.
So it lets you feed new data in and get the program that the computer created.
Exactly.
That .h file is not a Go file.
It is not a Go file.
So.
But when you load it back in, the Go compiler at compile time will load that in so that it has the same functionality that your Go program did.
It's not compile time, it's a runtime.
It's runtime. That's what I'm getting at, is that this is a dynamic program that's running. Basically, you're passing through from your compiled program to a dynamic program. You have no control.
I would assume, it sounds like if you build the program and then you run it once, put different .h, run it again, then you should be able to keep changing that .h.
You can. I'm saying when you load it. So right now, we're not using the load function. There's a separate load function.
Right. But when you load it,
When you load it, it'll be the same as deploying your binary file in Go, right? Because you're not resaving it. You're only using that one program.
So like reflect, right?
Mhm.
It's dynamic. Even though you've written it in a compile time fashion, right?
Mhm.
You're still going through the runtime to get to some result. That's what this looks like here to me, but I'm not sure. But you're going to load that file into memory. Go is going to basically map between whatever the .h file back.
Probably, that's probably how it works.
but I'm guessing in its simplest form, the .h is a serialized version of some
Yes.
structs, right?
That's what it is.
That's probably all it is.
And the main reason I'm asking is because.
Oh, I'm saying the
how
tree,
big
the tree will be a struct of information.
The tree will be a structure.
We were,
Yes.
there's going to be like 100 gig H file and you can't load that into memory.
Oh, heck no.
Even if it's a 2 megabyte, right? And every
The
time
H file is your
loading it.
parameters.
Well, but you'd load it, you do the load once and then
It's only defining.
But it is, it's not free.
You're looking
And you do some, if you're not smart, you load that every time you run the function call. I don't know. I'm just looking.
You could.
Because
No, I'm saying if you could reload it every time you get in the function call, it would not slow you down that much if you're trying to be efficient. It's not going to kill you on efficiency. There's probably smarter ways to do it, as in run it once and then have a separate function that pulls it in and does all those things, but that's what I would do.
Then you compile it down.
I do not think that's currently how it runs. Is that a better solution? Yes. It's just, the problem is a lot of the methodology around machine learning is a Pythonic in nature. So we're trying to adapt those Pythonic processes to Go. So there's still a lot of work that needs to be done to make this more Go-ish, less Pythonic in that nature.
That's all I got for now.
Oh, you're good. I hope I answered. Now, take what I say as a grain of salt, because I usually just BS most of these things, but we're putting all of this on YouTube, all of my lives, just so you know. Oh, where'd the rest of my slides go? Did I not put the rest of my slides up here? Well, that's it. I thought I had all of my stuff on there. Oh, well. That's it,
Show us
guys.
the .h file then.
Yeah, I was gonna pull it up. Oh, look at that. Who did that?
Oh, there
That
it is.
idiot.
If you like those colors, you can just say it. We're not going
I
to judge
do
you.
not use this color ever. I only put it up there. I changed this today to take pictures because I thought, oh, why would it stand out against a dark background? No.
It's not even white stuff.
So, like
Stupid.
90s feels almost. I don't know why.
Color scheme, where's my dark?
Was.
See, there you go.
Yeah.
So you want to see the .h file?
Yep.
Do it anyway.
It's binary. Oh.
That's your .h
I
file.
bet you the Onyx file
It's not a
isn't
.h file.
binary like that. I bet you
Not
it's.
like the only one I've ever seen.
Yeah, VS Code thinks.
You were thinking what, C or C?
Yeah.
A header file? Yeah, no, it's
It's
not.
not a header file.
How long does these take?
I thought, like, you'll see, pixels and
No,
stuff in a .h file.
no.
Those things will give you an
So
icon.
if you want,
.h file.
so Go Learn in itself. Oh, come on. Where's my Go Learn? There we go. No, that's still the wrong one. There it is. So the Go Learn, this is what I was doing today, guys. No, that's still the examples. There it is. So if you go outside of examples in the actual logic of it, the linear models, see, we do have some nice header files in there that are a lot more. This is the gross math that somebody else will implement every time. All you're doing is you read in this. See, this is what the train function actually does. Calls
The other thing we're including a .h file. That is a dot.
Yeah, see, it's included. This is Seago that I was talking about.
But it's commented.
Well,
So-
the idea with Seago is you run a separate compiler, the Seago compiler,
You've got a-
and it takes any commented code above the import C and interprets it as C. So that's how Seago works.
That's evil, but okay.
Does,
A Seago is evil in nature.
Evil, but
People that do Go do not like Seago, but it serves a purpose. The purpose is there are some things in C that are good, nice to use. And so we try to, you can put any function, you can write functions or imports, anything in a commented line directly above the import C, and that technically can be compiled and used in the Go program via Seago.
you know, do they use the same C libraries for this they do in Python? Because Python has Python, and you can kind of,
So
You
they
could, like,
do
share
not,
code
so
between-
this one specifically,
okay.
is it's either using internal C files or just standard library files, such as the standard library math file.
Okay.
They're not doing the internal stuff that Python would have.
Okay.
They've probably re-implemented a bunch of stuff, but the idea is Python libraries are big and heavy and weighted and just basically wrappers on wrappers on wrappers. And this is a lot more lightweight, easier to use in your training implementation. Personally, I think there's a lot of improvements that can be made on this package to get rid of some of the C stuff and do it more in Go. A lot of the original implementation of this was done probably 3 or 4 years ago, and Go's changed a lot since then. But it's basically speaking not like It's not hard to use, and some of the models could be used in production pretty reliably, like the linear models specifically.
Or the rest of the models kind of up in the air?
I don't know if up in the air is what I would say. Why is that so gross looking? I would say they aren't as vetted as some. Why am I getting this weird stuff going on? Vim broke. There has been a lot of refining done to the Python models in Scikit-Learn and SciPy and NumPy and all that stuff. This was one person who kind of wrote it with a couple of guys helping him out, as opposed to, you know, hundreds of people having touched the code and refined it with purposes for academic accuracy. So the linear ones are safe because it's not hard to screw up. You're going to get better accuracy with Python models for most of your more complex cases. But hopefully, with a little bit of work, this will be, all of the ones implemented in this one will be ready to use in any situation.
But use Python to generate the models and then just run the models in runtime with Go.
If you use Onyx, yes. With Onyx, yes. You could save any model in Onyx and use it at runtime and Go.
How long did it take to train the Twitter model?
Well, with just one tree, 15 minutes. I only had 7,000 words.
So if you took a billion word data set, what do you think that would come?
We're not doing any hard models, so it probably wouldn't end up being that bad, probably an hour at most. Things that start limiting you are CPU, benefits of Go. Oh, Vim's broken, that's what's actually happening. So that's why none of my things will work. So CPU starts limiting. So for example, when I tried to train 4 things with with 4 separate Go routines, I kind of maxed out my CPU and none of them trained. So that didn't work too well. But if I wanted to train them in order, that worked, and I could train about 1 every 15 minutes.
You're probably screwing, in that case, you're probably screwing it all up with context switching. You could probably train for it simultaneously.
Oh, there's no reason why I couldn't train 4. I just had to be a little bit smarter about it.
Oh, okay.
Go ahead.
Well, this is a Go meetup, so this question was,
I'll answer any question.
so why are you drawn to this Go mode over other code? I mean, what is it that makes?
I like Go.
Okay. You don't need any more justification. than that. What would you tell your boss?
To use Python in production.
Okay.
No, and it's very common. This is everybody I run into will tell you Python is better for an enterprise production use case because people work on the issues. The models generally perform better. They're trained better. The libraries are just better maintained. But Go's a better language than Python. I'll always say that. But I do all of my production ML work in Python.
I told you that Jeremy Howard was moving to Swift because once in a while you had to have Python in the inner loop other than just glue, and it just does not perform.
Well, Python's gross.
But yeah, you might be able to get away with that over, you know, because there are people that are frustrated with Python and machine
I
learning.
don't know, though. There's definitely Go could be a strong machine learning language in the future. The only thing holding Go back is community support on the machine learning libraries, right? If we could get somebody, Python has a lot of nonprofits that specifically pay people to maintain things like SciPy, NumPy, Pandas. TensorFlow is maintained by Google. PyTorch is maintained by Facebook. Like, you've got big companies and nonprofits putting people on maintaining these projects, iterating on them, making them better with every new version of Python. And that's going to win out besides some people checking bugs between 2 a.m. and 4 a.m. in Australia because that's when they're
So
not
how
doing their
many
day job.
communities behind this go or?
Where's my Slack channel? Behind GoLearn, there's like me. The person that originally wrote it is not active.
Machine learning libraries, is that what I should get?
Yeah, you should say machine learning. So active development, GoLearn is not under active development unless you want to consider the time that I fixed the bugs 4 months ago in March. None of the models were working in March, so I went and fixed them all. So yay me. So in the data science channel, there's 1,500 people actively working on. So GoNum has 5 contributors. Gorgonia, I think, has 4 contributors. Onyx has 1 contributor. Nobody's working on the Go for TensorFlow, I think, has a couple. GoLearn, like I said, there's no active development. Sajari is a company that has a linear regression model and a word2vec that they do use in production, but that's 2 models. Like I said, if you want to, that's just a linear regression and then a wrapper around word2vec, so you can do vector matching on words. So if you want to have any NLP uses. Other big ones, there's GoNum. For statistical stuff, there's a couple. GoHep is one made by a French scientist who works at CERN for his statistical stuff. GoNum does plotting and does statistical analysis, statistical math. But those are the same 5 people that work on both of those. And that's about it. So probably 20 people are actively working on this in the entire that I'm aware of. So that's the difference. So we need more people that we built. They always say, you'll get it at every conference, they say, we need more people to help, but who are we getting to help? So
You need a company that's committed to not
there you
just
go.
use.
That's who we need to help.
You need someone that's not just going to go, well, Python exists, we'll just use that, right?
I just need to convince Weave to pay me to do active development on these.
There you go.
And then we're on a roll.
There needs to be provable business value to doing it in Go versus Python, and I think that's the problem. Is
Well, you can't have
And you-
provable business value till the library.
I know, but that's what it's a chicken and egg problem. Like everyone's be like, well, it doesn't.
Well,
Why would you pay someone to write this thing in Go when we get in Python right now? And I'm just arguing
be
the way
fair-
it is, not what I
To
want.
be fair, Go is the best language. But so Java is the second most used machine learning language right now because of all of the enterprise companies that have their entire backend in Java. Why use a second language? So as more large companies use Go as a primary language, that could push people to start doing this. But people just tend to write their own tools and not open source them because they want to keep their secrets and they don't have a good division of tooling versus models. So you get back to the same problem, but that's kind of the idea. Is there's a hope upon hopes that if people drop Java and use Go, we'll get more support for these libraries. But it's a hope upon hope, not really an actual plan. So I'll convince somebody. Someday somebody who doesn't sleep will be on my side.
Become a nonprofit.
This? Oh, I am a nonprofit. Not for machine learning. I do the nonprofit for meetups, not for machine learning yet. So yeah, the machine learning channel has 115. The deep learning channel has 200. Data science just has a lot of people because this channel's been around for 4 years. But people that are active in it, it's like, there's just a couple of them. See, look, this is my French friend who works in CERN. He responds to me all the time. This is my Australian friend. He wanted me to apply to a talk. Where's my other friend? I asked somebody for a code review the other day. He lives in Germany, and he's doing all the Onyx stuff. So, yeah. Do we have any more questions, or are we just gonna call that a day?
So if I go try this, obviously.
Yeah, you can try it.
So I could,
You can,
Ask you
all my
questions.
stuff's on the GitHub.
but if someone can't ask you questions, how do they? The tutorials that they.
You join that channel and ask around the channel. That's
Yeah, so you ask me on Slack.
Okay.
So I would say if you want to use GoLearn specifically, I'm trying to get to the GitHub. GitHub.com. So I have a fork of GoLearn. And in my fork, I want to take, so if you go to GoLearn, you can go to the original GoLearn or my GoLearn. Mine's better because I have two.
You fixed it.
Well, they did push my fix up.
Say, you should be merging upwards if you.
It's not a hostile fork.
No, it's not. I merge all the things up. We're not that far diverged yet. So I just haven't pushed my examples up yet because they're not quite where I want them. But I just have a couple extra examples. I have this isn't my branch. Nah, that's fine. So I have the FIFA example where I'm going from raw text file through a parsing all the way down to putting a model into basically a production ready format. I'm going to do a second file that would then replicate that, what you would need to do to get into production. I also put in, where's the second one? I didn't push it up. I haven't pushed it up yet, but I also today put in a second example for a linear regression. They did not have a linear regression example in there. They had their k-nearest neighbors, and they had their a couple of perceptron, just different kinds of things. But you can go through they have pretty good comments on there. They also have a wiki on their page, I believe, that we'll walk through. Oh, is there not a wiki? Yeah, see, there's a wiki on their GoLearn that'll run through some examples and how to do things in there. If you're really, really like dead set on doing machine learning in Go, then I suggest Daniel Whitenack did the machine learning in Go at GopherCon that I helped with. He has I really need some water, guys. Oh, look, I have some. Arden Labs, where's my Arden Labs? So I don't want it inside of GoLearn, I want it in on GitHub.
So is there a deep learning example?
Yes, in the Arden Labs one there is. And so the GoLearn model doesn't do deep learning. If you want to do deep learning, you have to go into Gorgonia, or we need to get some PyTorch stuff. I use PyTorch a lot. I want this to be user, Arden Labs, there we go. So if you go to Arden Labs, they have an AI trading, and then they have machine learning with Go. So that's actually more of a walkthrough step by step on how to do things. It'll tell you basic tools for understanding the data. It'll tell you how to plot it, and then run through linear regression, logistic regression, and I believe they do k-nearest neighbors as opposed to the decision tree that I did. And it goes pretty well. They also have in here an example of how to deploy to production with Pachyderm, which is just a pipelining tool written in Go. So it's a little bit farther. So this is the most comprehensive. I think Daniel Whitenack has another one that we did. Oh, I want to be on his actual page. Did I fork that one? Yeah, so there's another one that I don't know if I forked or not. Yeah. Nope, that's not it. Nope, that's this one. So this is the one that we used for this year. So if you go to GCML, we have deep learning, linear regression, logistic regression, an example of how to implement your own neural network from scratch, with some README and then the slides that you can go through that. So I would say that's probably the best tool right now to get started with it on your own. Okay. I can share those links later on Slack if anybody's on Slack, the Forge Slack. Any more questions? Okay, what do I need to, besides changing the color of the text?
I would add just a couple lines from the CSV ahead of when you start using it, just because it was kind of a jump. You said it was in it, but it'd be cool just to see, like, here's the CSV with The first couple.
Okay, like
just
a
couple
an
lines,
actual table view.
or just the raw.
Well, yeah, but I'm just saying CSVs and the raw look like a table.
Right.
Yeah, more of a table view of it.
Just because you use the data, but we never actually see what the raw data looks like the first time you reference it.
I agree. The data frame was not as nice as if it had been in a Jupyter notebook where I could throw HTML on there and make it pretty.
Well, no. So if you go back to your slides, I'll.
Oh, I know what you're talking
Okay.
about. I'm just saying, in a Jupyter notebook,
Right, you
can wrap the HTML around it and it looks a lot better. Right here, it's kind of gross. You don't see anything valuable.
Oh, it wasn't even clear to me. That makes more sense.
This is a data frame. This is a table.
I see. I didn't realize that was the data coming out of the CSV. I would like all I really want to do is type the word head, say head data.csv, and just see what that.
So there is no, okay.
That's what I was. Maybe it doesn't make any sense, but.
I know, I can switch this out for someone clear.
No, that.
No, I will change the site. Note.
Or
Carson.
No. Do the CSV first, and then do the more pretty tablified version. But maybe I'm just a
need
low-level guy.
better flow for understanding
the raw data.
what is in CSV file.
And I think.
I thought you were calculating this. I thought you were
Oh,
like.
no, this is just a pull from the CSV file.
I think okay. That yeah. I was
I'm
like.
gonna put right here the
Head.
code example is hard to read in a growth color. Okay, any other?
And you should keep in that all of machine learning is a big switch statement. You should-
Okay, I'm gonna,
I'm gonna take that out now to think.
this is not going anywhere.
Keep that.
That's 100% true. I mean, it's not what it looks like, but it's what it does.
So the GIF animations,
You don't like them?
I like them. I love GIFs. And I like those GIFs too. They have good GIFs. Just having a slide full of them, or having a slide that has them that's going to stay on the screen for a long time is like really distracting because you're talking, you're making.
Oh, you're saying I should have a click, pull them off?
I would probably play it a couple times, pause it, or move to the next slide so that it's not just constantly animated, stealing all your attention away from you.
Okay. Or talk less.
You could do that.
Or just sit there and look at the GIFs with people for a while. Just silently, like, let's all watch this GIF.
Yeah.
Make the GIFs just explain the whole talk.
Well, that's what I was trying to do, but I could, let's work on GIF explanation. The images are too distracting and you talk too long.
No.
I actually think you're going.
No, I do, I know, I could be more concise about the explanations is what I'm trying to get at. I ramble. It's just, I just need to practice being a little bit more concise about those explanations.
I want to see like 6 more faces that they generate though.
Do you want to see that?
Yeah.
I was curious too.
Oh,
Not a face.com or
there's
what?
like
This
one-
person does not exist.com.
Oh, really?
Yeah, they have one for anime. So like it'll.
Oh, yeah, I bet they do.
They have
So, yeah, so you just like,
That pretty,
I've seen that
They're
person
Oh.
before.
they're made with real faces, right?
right.
no, so they take, so they've had millions of faces they pulled in. And so it notices characteristics, right? So these aren't meshed together of different people's faces. It's like, oh, I know that this is a real eye shape and that's a real eye color. And so it just kind of, it's not actually taking.
It's not Photoshop like
It's
putting
not,
photos
it's
together.
not, it's not like pasting parts together. It's just saying,
Creating.
it's creating something based on, but you can notice weird things like the teeth are off. And she's got a weird neck thing right there,
Yeah.
right? The hair's kind of lerpy.
What she's standing in front of, who knows? The eyes, what I notice a lot is
I noticed the eyes are like sometimes.
Yeah, there are
pointing in
things that
different
are really
weird
hard to get
directions.
right.
they're like chameleon eyes
But
sometimes.
to be fair, these look more like a real person than a lot of the CG animations that you get out there.
Oh, yeah.
Because faces are not necessarily symmetric.
Yeah. So there's a YouTube channel I watch where they do VFX stuff, and they do a lot of the time they'll compare deep fakes to what people do with CGI. And deep fakes, they're really good at mimicking facial expressions, right? So they may not get textures right, but the faces don't do weird, movements out of place. So those are the kinds of things that these GANs and these neural networks will pick up that we cannot manually replicate. That's why these things often look so real. That one's actually pretty good. That's like a sweat drop right there.
What's the cat's button by next to save? I have to know.
Oh, you want to see this?
I have to, yes.
I'm pretty sure it generates cats.
This cat does not exist? Oh my gosh.
They're just generated cats.
That's amazing.
They also have like conversations, like they've replicated scripts, like they have a friend script that they'll like start a conversation and they'll generate conversations like esque of what they would have done in a Friends episode.
I would almost be tempted if I was you to have my first slide be like 3 pictures of people and 3 pictures of cats and just start out say, none of these are real pictures.
That's what Ben Taylor does, though.
Is that what it is? Okay, I haven't seen it. Okay, so it's not a bad
He's
idea.
way too famous for me to rip off.
Okay, no, I haven't seen
I
that.
am
So.
not that famous yet.
Well, I haven't seen it, so it's not famous for me.
If you do it at like
Ben Taylor's
a board,
huge.
if you do it at a board meetup, then he might not go, and then
So we're
Came to one of our meetings a couple months ago.
went to the Nav one too.
Yeah, anyway, so they
what's happened to that? He's missing a chunk on his side.
it just happens to be the same color as the carpet.
Oh,
Come
okay.
on.
I'm sorry. I got worried
Cool.
for that fake cat.
Okay. Well, we got plenty of spits in there, I think, still left. If somebody wants some more food, I'll be happy to take any more questions, but I'm going to stop the Zoom recording and call this a YouTube ready.